Hello and welcome to today's Problem Spotlight. This here's a problem from the AOP Summer Math Camp I recently completed about logic and middle school math competitions. So this problem, involving marking regions, forces you to use logic and trial and error to solve it. So this here marking regions problem states that mark each region on this map with the number 1, 2, 3, 4, so that any two adjacent regions have different numbers. What number must be written in R over here? So this looks like quite a complex diagram. So since this has so many different regions, like this is a region, this, and even this, these are all regions. So for something like this, what you want to do to start off is just plug in some numbers just to test out and not actually think about strategically solving this until later on. So you want to get somewhere to start with. Let's start off by, I just chose a random number, like 3, for example, to just put up in the corner here. So we're just starting off by trial and error here, just to get somewhere to start with. And since any two adjacent regions must have different numbers, I looked at the adjacent region to this. Well, this is adjacent, so this region must not have a 3 in it, and this must not have a 3 either, and this must not have a 3 as well. So then I put a 2 in here, just to experiment. And since this region cannot have the same number as this would have to be 1, since if it was 3, it would violate this region. If it was 2, it would violate this region. So I put a 1 in here. And then over here, I did another trial and error and just put in a random 2 over here and worked from there. That's an important technique, just putting in random numbers and then working from there, especially on, complex problems like this. Okay, so we have a 1 here, a 2 here, and a 3 here. Now, if we look here, there are several regions that are adjacent to this one. Like, for example, there's this, and this. They're all adjacent. So, and actually, in the original problem, they gave us a 1 and they give us a 3 here. So we have this additional information to work with. So if you know this is 1 and this is 3, this must be a 2. Otherwise, it would violate all of them. So we just add a 2 there. That's easy. And then, over here, this has to be a 3, because if it was 2, it would violate this. If it was 1, it would violate this. This must be a 3 in here. Okay, now you can see it's relatively easy to fill in this, because we only have one number left, 4. So, because if you put 1 here, it would violate this, and 2 and 3 would violate these, and not to mention that. So 4 must go in this circle here. And then there's this section down here, which is overlapping with this outer ring over here, which is a region itself, and the circle. So I just plugged in another random number, which actually this does not overlap with this. Supposed to be not quite touching there, but I put in a 4, which means that for this region we must put a 2, because this does not touch that. And 2 is the only number that does not, it's not the same as 1 or 3 or 4 here. So we must put a 2 over here. And this 2 fills this entire region over here. This entire area. Okay. Now, let's see. Have we filled in everything? See, I think we filled in every single region with the appropriate numbers. Now, what they want is what number must be written in R. So we can figure out R easily from here. We've got a 1, we've got a 2, we've got a 4, and another 2 over here, leaving the only possible option being 3, which means that R must equal to 3. And that's our answer to this very interesting marking regions problem that I solved in class during the camp. This is a problem where you actually want to use trial and error and kind of guess and check to give you some place to start with, so that you can then work from there and fill in the rest of the diagram through process of elimination and just using general logic.